Dear students, myself Dr. Sahab Basha, working as a professor in Department of EC, G. Polaroid Engineering College, Kurnool. As a part of curriculum, for you, EDC lab is there. In this EDC lab, one of the topic that is rectifiers and filters is there. In this particular topic, for this particular lab, I am going to give the demo related to the performance characteristics of the half wave rectifier. So coming to the block supply and other is a switch mode power supply is there. We are mainly interested related to the linear mode power supply. In this linear mode power supply, the main intention is we want to design a power supply by using these rectifiers and filters. The direct AC load line cannot be given, so we have to have this AC to be converted into DC. So this AC line is going to be given to a transformer. This transformer is a step down transformer, what you are going to use here. After stepping down, that is the concerned voltage and voltage, we are going to connect to a rectifier. The functionality of the rectifier is to convert the AC to DC one. So these rectifiers are again classified into half wave rectifier is there, full wave rectifier with center tap is there, and bridge rectifier is there. After rectification, we are going to give for the filter, where there are different types of filters are there, but in our lab we are going to have the C filter here, capacitor filter. And from here we are going to have the respective performance characteristics for both the rectifier as well with filter and without filter. This is the half wave rectifier. In this half wave rectifier, you can see this is the step down transformer. The primary is connected to 230 volts 50 hertz, and whereas the secondary, what we are using right now is a transformer of 12012 rating. So in this one of the winding we are going to consider, that is 0 to 12, that is 12 volts I am going to consider here in the step down concept. And one diode, it is what I have mentioned is IN4007 I am using here. And ammeter with a scale of 0 to 500 I am using. So scale what I mentioned is 0 to 255 in the circuit, but we are having 0 to 500. Higher scale we are going to consider. And a load resistance, this is a variable resistance where I will show you it is a pot, or you can say variable resistor, so that we can vary it, and by that variation we can measure the constant current and the respective voltage, that is VSC and also the VDC. This is related to the half wave circuit, half wave rectifier circuit without filter. The same circuit if you want to have with filter, only thing is the additional capacitor is going to be added across this load resistor RL. This capacitor also one of the additional device where we are going to use here. The components that are required for this performing this particular circuit is, one is step down transformer is required. You can see here in the concerned list. 12012 transformer, and one breadboard where you can stuff the concerned components and take the respective readings. And we are having one IN5007 diode, a capacitor. What right now I am having 63 volts with 1000 microfarads, and you are having we are having an ammeter that is 0 to 500 milliamps, and one variable resistance of rating 1K is there, and one multimeter is there. These are the and some connecting wires. These are the components that is required to perform the half wave rectifier. Now we go for the experimental determination, that is how to do the concerned experiment. So coming to the board, so this is the breadboard. So where you can perform the experiments. You can see here there are 4 columns that have been mentioned here. The above one is this particular connectivity is in horizontal connectivity. You are having 2 rows here. If you connect here, you can get up to this one. So totally 4 sections are there in the above one. So from here to here one section, and here to here this other section. All these particular holes are horizontally connected. Suppose if you are going to connect the component here, you can get the connectivity up to this one. If you want to extend this one, you use a jumper here so that you can connect up to this one. Similarly, at the bottom of this one, this is also the same thing. This is going to be connected horizontally. The center part is divided into 2 sections. This is one section and this is another section, and this is totally isolated. Here it is vertical. each row you can see here, this suppose if you are going to connect here, you will be getting connectivity up to this one. If you want to have the connectivity in the second section, you have to make a jumper here. So this is the workstation where we can put the components and perform the things. Now as per the circuit, I am going to connect the components. So IN4007 diode I have used here. So you can see a black body is there and with a silver band. So this is the black one is said to be anode and said to be, this is the silver body said to be cathode. So I have put in two different holes here. So anode in one side and cathode is other side. And for this one, the other component is the transformer. You can see here, this is the transformer. So I will show you, this is this transformer, what I am going to connect here. This is the transformer. The transformer, you can see on this body, a sticker has been pasted with a rating 12012. So this is the 12012. Extremes, if you are going to take the value, what is the voltage, it gives 24 volts because 12012 is 24. If you are going to have the center one, that is from here to here is 12 and here to here is 12. So for the full wave rectifier, we want to have the center tap. For that purpose, this is used. Whereas for the half wave and full wave, this is not used. So you can use for the half wave any of the particular lobe, this one or this one. If you are going to have the extreme, you can have 24. If you want to have the center one, you can have 12 volts. So this is the primary winding. This primary is directly connected to the AC mains. So now we are going to connect one of these winding. So as per the circuit, you can see the circuit. So one winding terminal is going to be connected to the anode here. So I am connecting here. You can see here this is connected to the anode. And second one, this is a terminal which is going to be grounded here. You can say this is ground, you have to add here. So on both the circuits you can have to ground here. So you have to go for the ground. Now I am connecting this another terminal to this ground terminal. Anywhere you can connect it here. I am connected to the ground. Next, what is an ammeter is connected after the cathode here. So here ammeter positive is going to be connected. This is a positive one. The cathode to positive. So this is the cathode. The other terminal is said to be cathode is this one. From this cathode, I am going to connect to the positive of this ammeter. So you see here, I am connecting to the positive of this ammeter. So this has been connected. Now the negative, you can put it somewhere so that you can have the connections. I am putting some other hole here. So the ammeter part is completed here. Now load resistor is there. So this is the variable resistor you can see. So the rating has been mentioned here. This is 1K. So you can use in any of the concerned method. So one terminal I am going to connect to the ground. So the ground terminal I am going to connect here. So you see this is the connectivity ground. Now this lead we have to connect at the terminal what that is negative terminal of the ammeter. This is the one I have connected here. And now 1 voltmeter, that is digital multimeter, has been connected here. You can see here this is the digital multimeter. So this is the positive lead, this is the positive and this is the negative. So positive is yellow. I am going to connect this yellow one to the terminal that is the multimeter positive one. So you can see here these all are in one row. So this makes a one connectivity. And the other terminal ground is going to be connected to the ground. Ground is connected to the ground. You can see here this is connected to the ground. Now this completes the circuit. So what you have to do is you can see the table, what are the readings you have to measure. Just a minute. Now you see here this is the table and the concerned graphs. We will later go for the graphs. First to go see the table, what are the concerned parameters have been tabulated here. You see without filter first we are going to have. First we have to go for the no load voltage. That is when current is said to be 0, what is the concerned voltage. First we have to measure this one. Then you can see the table here. One is load resistance, next DC, VDC, the output DC voltage VDC, output DC current IDC in milliamps, ripple voltage that is VAC volts, and ripple factor, ripple is calculated as VAC by VDC. VAC by VDC. And other is percentage regulation, that is V no load minus V full load by V no load into 100. So this is the table where we have to take the respective readings. Now we will go one by one how to perform the experiment. So just come, first we have to remove the concerned lead, this one of the terminal of this variable resistor. I am removing this because we don't want to have the load. First no load condition we have to measure. So no load condition, and we have to take this multimeter in analog one to have a fixed value for this one, analog meter. Now I am switching on this circuit. So you can see on the voltmeter, it is almost 6 volts. Is it clear? I think it is 6 volts. It is showing 6 volts. Now you see here, I have mentioned the value on the table, that is no load voltage is 6 volts. Now next we are going to distribute this, how to take the readings is from 25 to 150. I am going to make it out. So first is 25 milliamps I am going to set, and with the frequent intervals 25, 50, 75, 100, 125 and 150 milliamp. So these are the things what I am to make it out. And this resistance I will show you by disconnecting this circuit, and we can have the load resistance, what value it has been measured. And apart from this one, we can also calculate theoretical from this VDC and IDC. This also I will show you. Now first we go for the first reading, that is 25 milliamps. Now come back to the concerned circuit. You see that I am connecting this variable resistor into the circuit. So the connectivity I have connected here. Now the load has been connected. Now I am going to switch on this circuit. Now this I am going to have, we want to have both the VDC and VAC. So I want to take up this readings from the multimeter. So this is in the DC mode. So this is the DC mode, and you can see here I am varying the resistance such that I want to have 25 milliamps. You can see the scale now on the milliamps one, that is 25 milliamps. I have set to 25 milliamps. Now you see the corresponding reading on the digital multimeter. That is somewhat it is going to vary. Previously I have took the values. That is, you can see VDC is 5.76, and similarly you change to the VAC mode. So AC, that is VAC, you can see that is 7.09. So these are the values. Now already I took some values previously. You can see here it is 5.72 for 25 milliamp and 7.02. I will show you another reading for you for clarity purpose. Now we go for the next reading, that is 50 milliamps. Now I am still increasing this value to 50 milliamps. You can see here that has been increased to 50 milliamps. Now you can see this in the milliamps, that is going to be measured as the 50 milliamps. It is clear, I think, 50 milliamps. Now you come back to the DMM, that is the digital multimeter, and see what is the VDC value. That is 5.56 approximately. Then go for the AC one. After recording this, I will show you the table here. That is 6.79. So I have noted the VDC as well as the VAC. Now come back and see the second reading, that is 50 milliamps. VDC I got 5.56 and the VAC said to be 6.77. So likewise you have to take up the values for 75, 100, 125 and 150. The corresponding values for this one is for 75 milliamps, it is 5.26 and this 6.4. For 100 is 5.14, this 6.23, and this 4.91 is 5.95. For 150 milliamps, 4.61, 5.61. Now I will go for the last reading so that it is clear for you. Just come back and see. Now I am varying this thing to 150 milliamps. So I have set the reading to okay, 150. Now you see this 150 milliamps. Now the DC value, you see first. DC value is 4.73 or something, it is there, it is varying. And AC value you can see that is 20. So this AC and DC. I will show you the measurement with resistance also. Now I am switching on the system. Now you see here this multimeter. another multimeter I am using where put the knob in the resistance mode, that is in 200 scale it is there. Now I am going to measure the value at the pot. So you just measure it. So you can see here the value what you got is 34 ohms. That is 34 ohms. So 34. Now the previous readings what I have plotted, you can see here, that is 30 ohms. Similarly for these values what I have noted, 25 is 250 ohms. If you calculate and see theoretically, these are the practical values what I have measured through the multimeter. Now you can see here the value what I am calculating here is the VDC by IDC if you take up. So you can see 5.72, go for this one, 5.72 divided by, that is 25 milliamp, 25 into 10 to the power of minus 3. So if you get the value, it is 228.8 is the theoretical value. You can see on the CAD-C. The same value if you measure directly from the variable resistor is 250. So your slight change is there. So it is acceptable. Now these readings what I have up to this one, these are the readings what we have took up from the experiment. And now we go for the ripple calculation. This ripple is nothing but VAC by VDC. That is 7.02 divided by 5.62. One value I will show you to you. That is VAC value is 7.02 divided by 5.72. You can see here the value is 1.227. So I noted as 7 is higher compared to 2. I put 1.23. Similarly, you have to calculate for all the other values. So you can see, you can notice here it is almost constant here, 1.23. A meager value has been increased, so up to 1.21. So nothing is changed in this one. The ripple is from 1.23 to 1.21 when you go from 25 milliamps to 150 milliamps. Similarly, we go for the regulation. Regulation is V no load minus V full load by V no load into 100. So again I will calculate one reading for you so that it will be clear for you. V no load is 6 volts, that is 6 minus the full load voltage is 5.72. 5.72 divided by 6, you can see the value is, you will be getting 0.04 into 100, so you will be getting 4.66%. 4.66%. So you can see the value here. Similarly, you calculate all the values, you will be getting from 4. There is gradual increase of the regulation here. So now what you have to do is we have to plot the consent graph with and without filter. Now we have done the experiment with without filter. You can see the graph here with without filter. So I have mentioned with is with filter and with is without filter. So for this first graph, IDC versus VDC is there. So IDC versus VDC, this is the IDC value 25 milliamps to 150 milliamps, and corresponding VDC value is 5.7 to 4.65. You can see there is a gradual decrease in this one. So as increases IDC is increased, VDC is going to be decreased. This graph is going to be clear from this particular table. So this is correct. Next we go for the other value, that is IDC versus ripple. If you see for the without filter, this one without filter, so you can see here ripple VAC by VDC we have calculated. For 25 milliamps it is 1.23, whereas for 150 milliamps 1.21. You can see is almost constant. You can see the straight line have been mentioned. This is without filter, this is a ripple. So IDC versus ripple. So this also is clear. Now coming to the other last graph, IDC versus regulation. If you see IDC, that is 25 to 150, again you are going to see that is going to increase from 25 to 150, and you can see the regulation from 4 to 44 it has been increased. So you can see without filter, so this is a gradual increase in this one. So this is how the performance characteristics of half wave rectifier without filter we have done. Now we go for the with filter. So in the with filter circuit, other things same, only thing is we are going to add a capacitor across this one. This is the positive and this is the negative one. So this is the capacitor what I have chosen here. So this is a 63 volts with 1000 microfarads is there. So this negative terminal, this is a negative terminal will be short one compared to the positive one. So this terminal I am going to connect across this load resistor. You can see here in the board. So in the board you can see this is the resistance all put together in one node is there. So I am going to connect this positive one. So you can see here this is the positive terminal I am connecting, and the ground any one of the hole here. So just I am connecting this one. So this has been connected. So first condition is, again come back to the circuit has been connected here with capacitor, that is with the filter you can say. Now the same table remains same, only thing is with respect to the filter we are going to take up is with capacitor filter. Now first we go for the no load condition again. In no load condition, first you have to disconnect the one of the connector of the resistance. I have disconnected this one, and now we will go for the first reading. So just I am putting all the things to be minimum here. So just I am switching on the concerned circuit. Now you see the reading here. So the no load condition, it is showing somewhere it is 19 point or so. So you can have this reading from this one. I will show you in the analog meter. So approximately it is 18 point something is there. So from actually what I have noted is it is 18.5. When we go for this one, it is showing 18.67. You can note the value as 18.6 somewhere. Now we go for the with load condition. When we go for the with load condition, you have to reconnect the concerned lead of the variable resistor. I am going to connect it here, so you can see the readings in the with load one. So I am going to put in 25 milliamps. So you can see the value there. In DC is 17.14, and we will change to AC value. It is 0.18. So you can see a drastic change in the VAC that has been dropped to in 0.16, 0.15 and 16. When you see the reading for the first one, what I have noted here for the 25 milliamps, this 25 milliamps, the VDC is 16.93 and the corresponding AC value is 0.15. We will go back and refer the previous one. You can see here without filter, that is 7.02. So this value is totally decreased. That means you are going to remove the AC components present in the DC using the filters. That is, you are going to minimize the harmonics in the particular signal. So this VAC value has been reduced to 0.15. Similarly, we go for the 50 milliamps. Note the VDC value, corresponding VAC value. Like this, you have to do up to 150 milliamps. I will show you one of the reading. The last reading I will show you here. You see, I am just varying the resistance, varying the pot resistance. So I am setting to 150 here. Now you see the scale. So this value, it is almost 150. Just a minute. Okay. Now 150 I have set that value. Hope it is clear for you. And now you see the concerned DC value on the digital multimeter. It comes to 11.9, somewhat varying that one, 11.995 or something. What I have noted at the time is 11.993, and corresponding AC value you take. So that value it comes to 0.8586. What I have noted is 0.79. Now we will come back and see the concerned values here. For 150, the VDC value is said to be 11.93 and the VAC value is 0.79. So now we have tabulated all the values from taking the resistance, that is IDC value from 25 milliamps to 150 milliamps, and the corresponding load resistance. This load resistance also I will show you for one of the readings. That is the last reading what I have done is 150 milliamps. Now I have disconnected the circuit. Now you can measure the resistance using a again digital multimeter, where I have put the value from the 200 ohms mode. And now I am putting the leads on the concerned pot here. So you can see here, this is the resistance, how much it is going to be there. The value that is going to be there is showing somewhere it is 98 ohms, 90. 8 ohms, just a minute. Okay. So what I have calculated here is 69. I am going to have in this one. I will calculate theoretical also this value. So for example, if I take the value VDC by IDC, if you take up, so you can see the calc here. I am doing the value, that is 11.93 divided by sorry, I will take in this form. So 11.93 divided by 150 milliamps, 150 into 10 to the power of minus 3. So you can see what is the value you will be getting. 79.53 you are getting theoretically, whereas for me practically it comes to 69 to 70 ohms. So almost nearing the value. So theoretical value and practical somewhat will be differing. So I have practically noted the values. It comes from 710 ohms to 69 ohms. Now these values we have calculated. Now once you got these values, ripple as usual what we have done for the previous without filter, the same thing we will be doing. So I will show you one of the value here, that is VAC by VDC, that is 0.15 divided by this is 16.93. If you see, you will be getting a value that is 8.86. So I will show you one of the reading in this one, ripple calculation, the last value for the 150 milliamps. If you see in this one, that is 0.79 is the VAC value and 11.93 is the VDC value. VAC by VDC I am getting 0.066, so 0.066. Similarly, we can go for the regulation also. You take this value for this regulation, the same value for considering. So no load voltage is 18.67 minus the value full load voltage is 11.93. So divided by 18.67. So you will be getting a value 0.36 into 100 if you take up. So you will be getting 36.10. So this is the value 36.10. You can see here the ripple value 0.009 to 0.06, a little bit like small increase in this one, so that doesn't make any change in this. And if you go for the regulation, you can see it is going to be increased from 9 to 36.10. Now with these values we have plotted the graphs also. The first value will show you for the IDC versus VDC. With the filter you can see this VDC is going to drop as you increase the IDC here. So you can see the IDC 25 to 150. This is the VDC value 16.93 to 11.8 is going to decrease. The same value what you are showing, this one is clear. Now same thing we go for the next characteristics, IDC versus ripple. So in this one a slight increase is there, 0.009 to 0.066 is there. It's little bit light increase, slight increase in this one. When IDC is increased, a little bit increase in the ripple is there. The last one, if you go for IDC versus and regulation, that is 25 milliamps to 150, if you see 9.31 to 36.1. So these values, if you take this one, so the regulation is going to be increased with respect to the IDC. As IDC increases, the regulation slightly it increases with the filter also. So you can see this graph. So this you realize this graph with respect to the readings what I have shown to you. So this about the half performance characteristics of the half wave filter rectifier with and without filter.